This presentation was prepared as a part of HAP 725 course on statistical process control. I'm Lata Kona and this Teach 1 is on Week 5's topic of comparison of means. I will be focusing on question number 1 that reads as in health administration programs conducting satisfaction surveys are usually covered in courses on quality improvement. This exercise shows how data from satisfaction surveys can be analyzed over time. Assume that in different time periods, 4 randomly selected patients rated their satisfaction with our services. Are we improving? In order to solve this problem, we need to create control charts. Control charts are used to examine how a process evolves over time and to monitor if a process is under statistical control. They're used to determine the presence of special causes of variation or identifying common variations. The way we identify special causes of variation versus common causes of variation is by using upper and lower control limits. These control limits creates boundaries between common cause variations and special cause variations. Everything that falls between upper and lower control limits is generally considered normal process variation. If we run into data point that falls out of the control limits, that should be a sign perhaps we are experiencing some special cause variations. Here is a brief overview and the steps that will be taken to approach this problem. So the first step is to import required libraries and load the dataset, and then we calculate the average for each time period and total average of all the observations, calculate the standard deviation for all observations and for each time period, and then we calculate the upper and lower control limits and create the chart. So let's go to the first step. The libraries pandas, numpy and matplotlib were imported and the dataset is loaded. The dataset has time period ratings of patients over each time period. The next step is to calculate average for each time period and total average of all observations in the dataset. The first line of code calculates average rating for each row. Here axis equal to 1 will perform mean operations for each row and return a result where each row represents mean of corresponding row's value. Skip NA equal to true. It skips or it ignores the missing values in the dataset while performing the operation. The next line of code calculates total average. Here, stack is used to stack the columns on top of each other. Axis equal to 0 calculates the mean of values in series or in columns. The standard deviation for all observations is calculated and then the standard deviation for each time period is calculated by using standard deviation of all observations divided by square root of the count of non-null values for each row in the data frame. From the output, we can see the standard deviation for all the observations is 4.35 and the standard deviation for the first 3 time periods is 2.17 and for the fourth 3.08. We should now calculate the upper and lower control limits. So the upper control limit for the given time period is the average for all observations plus t times the standard deviation for the time period. T value depends on the number of observations and the confidence interval used. Here 1.96 sets the limit so that 95% of data falls within the two limits. The next step is to plot the chart. plt.figure is to initialize new plot with width of 10 inches and height of 6 inches. Time period is taken on x-axis, satisfaction rating is taken on y-axis, and the average rating, upper control limits and the lower control limits were plotted. The title and lesson was added, and the grid is also added to make the plot easier to interpret. Finally, plt.show displays the plot. Let's analyze the result. The upper control limit and lower control limit for the fourth time period is wider than other time periods. This is because fewer data means less precision and wider limits, and there are only two observations in this time period. This also indicates larger standard deviation. The average rating for the first time period is on the upper control limit, and the average rating for the second time period is below the lower control limit. To conclude, patient rated services higher in the first time period but lower in the second time period, in which the ratings were not due to chance. This clearly shows the changes in satisfaction from one period to the next, and this information helps to focus better on improving the performance across all time periods. This concludes my presentation. Thank you for watching and feel free to let me know if you have any questions.